Okay, this lesson is an algebra review lesson on simplifying radicals. It's technically in chapter 7, but we don't use it till chapter 8, so that's why I put 7 and 8 at the top. One thing we're going to be talking about is what is a radical expression and then how to simplify it. Okay? A radical expression is anything that has this root symbol on it. Okay? If the index, which is the little number outside, is not written, it is considered to be a 2. If it is written, then that specifically tells you how many identical items must be under the radical sign in order to come out. Usually we don't work with anything but 2's in geometry, but when you get into algebra, well, even when we start to do volume, we'll work with 3's. But for the most part, 2's is your main objective. When we go to simplify radicals, if it's already a perfect square, for example, in your previous math lessons, you've learned that the square root of 4 is 2, and that's because 2 times 2 equals 4. 2 identical items gives you that number, and the index, since it's not stated, is a 2. That's how square roots work, okay? That's how radicals in general work. If you were looking for the third root of 8, it would be what number times itself times itself. So 3 numbers that you would multiply to get this number to get 8. And so the answer to the third root of 8 would be 2. Okay, so simplifying radicals. There's a few different ways to do it. First of all, if your number under the radical sign has a perfect square as one of its common factors, or as one of its factors, then you should break it up into the biggest perfect square that's inside that number, and it would be a prime number then that goes with it. For example, the square root of 50 has a factor of 25. 25 is a nice perfect, nice perfect square. So the square root of 50, we would break that up into the square root of 25 times the square root of 2. Because 25 times 2 is 50. We break that up because the square root of 25 can be taken. We can get the 25 out from under the radical sign. Because 5 times 5 is 25. We can take the square root of 25 and get 5. And then the square root of 2 can't be simplified. 2 is a prime number. It would stay stuck, so-called, under the radical sign. So our simplified answer to the square root of 50 would be 5 outside of the radical sign and 2 under the radical sign. That would be the simplified answer to the square root of 50. As far as the square root of 147 goes, the square root of 147 has the perfect square 49 hidden in it. So we would break up the square root of 147 into the square root of 49 times the square root of 3. The square root of 49 we can take. The square root of 49 is 7. And the square root of 3, 3 is a prime number. It's stuck under the radical sign. It does not reduce. So we leave it under the radical sign. So our simplified answer to the square root of 147 would be 7 times the square root of 3. When you get into problems that aren't just one number under the radical sign, sometimes you have options. And sometimes one option might work better than another, or one option might be more obvious to you to use than the other. It really doesn't make any difference. When you're multiplying radicals, you can combine the numbers first, or you can take the radical first. It depends what they give you. In this case, neither one of these are a perfect square by themselves. So if I put them together, maybe there'll be a better perfect square. So I take the square root of 8 times the square root of 2, and I'm going to multiply those and keep them under the radical sign. That would give me the square root of 16. 8 times 2 is 16, and the square root of 16, 16 is a perfect square. That makes it easy. The answer would be 4 outside of the radical sign. So sometimes it's nice to put them together before you square root. Sometimes it's nice to square root before you do anything else. In this case, the square root of 4 is on the top and the 3 is on the bottom. Since there's not parentheses around these, only the 4 is under the square root, the 3 is not. So I can easily take the square root of 4 into, or outside of the radical sign and get a 2 over 3, and then I can either divide it out and get my decimal, or I can leave it as 2/3. That would be as simplified as it can get. But in this case, I wouldn't want to put anything together. Not that I could, because one's under the radical sign and one's not. But that's the kind of thing that you have to be aware of. Sometimes it's better to put them together. Sometimes you have to do the radicals separately and then do the rest of the problem. When you're dividing, it's the same thing. 294, when I divide that by 3, I get 98. So 98, I can break down 98, but I might want to look and see if there's another option. I believe that I will take the square root of, or I think I will divide them first, since there's 294 isn't a perfect square, and 3 obviously isn't a perfect square, so I think I'll divide them first. When I divide 294 by 3, I get the square root, like I said, of 98. Now I only have one number to break down, and if it has a perfect square in it, then life is good. If it doesn't, then square root of 298 is as good as I can get. It does happen to have a perfect square in it. 49 times 2 is 98, so I can break this up into the square root of 49 times the square root of 2, and the square root of 49 is 7. So I get 7, and then the square roots of 2 is what's left. That would be the simplified answer to the square root of 294 divided by the square root of 3. There is a restriction on dividing by square roots. When you have a square root in the denominator, it cannot stay in the denominator. In your final answer, you cannot have a square root in the denominator of a fraction. So if I hadn't divided these and gotten 98, I would have had to get rid of the square root of 3 anyway. The way that we do that is something called rationalizing the denominator. When we rationalize the denominator, and I'm waiting for the next screen to come up, sometimes it takes a minute for that screen to change. Sometimes it takes longer than others. It does not want to move to the next screen. There we go. Okay. So we do something called rationalizing the denominator. In this case, I can't take 4 divided by 3 like I did on the other page. That number was divisible by 3. This one's not. So the square root of 3 is stuck in the bottom. So what do I have to do is I have to eliminate it. I have to get rid of the square root in the denominator. The best way for me to do that is to do something where I make the denominator no longer a square root. Okay, so I'm going to start square root of 4 over the square root of 3, and I want to get rid of the square root of 3. The easiest way to get rid of that is to actually multiply it by itself, because a square root of anything times itself is just that number. That's the easiest way to get rid of a square root, is to multiply it by its exact self. The square roots they kind of cancel each other out, so to speak, because it becomes the square root of 3 squared, and so the square root and the square would cancel each other, and 3 would be what I would be left with. Another way that you can look at it is you could actually multiply them and get the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 you can take as 3. However, if I multiply the bottom half of my fraction by something, I have to multiply the top part of my fraction by that same exact thing. In this case, then I would multiply and I would get the square root of 12. Or I could actually take this and take the square root of 4 and get 2. But either way, I'm going to have to break down this number. The easiest way would be to the square root of 4 times the square root of 3 is the square root of 4 is 2, and the square root of 3 would stay under the radical sign. So you would leave it as 2 times the square root of 3 over 3, and that would be your answer. 2 over 3, 2 and 3 are both outside the radical sign, so if they are reducible, they are a fraction that you would simply reduce. If they're not, like 2 and 3 are not, we leave them just as they are. I broke down, you can either break down the square root of 12 into this number, or you can look at it as 2 times the square root of 3. Either way, you'll get this for your answer. And 2 over 3 is as simplified as it can get, so this would be it. You no longer have a square root in the denominator. That's how you rationalize the denominator. This is the same type of problem here. I have the square root of 5 times the square root of 3, and I'm dividing by the square root of 6. Now, I'm dividing, so if I can simplify these, I might as well do that. Okay? I can simplify 3 over 6 as 1/2. So I can take the square, I can reduce this down to 1 over 2. So this would be the square root of 1 over the square root of 2. I'll rewrite that. The square root of 1 is just 1. The square root of 2 is nothing nice. So the square root of 2 is stuck in the denominator. I'm going to have to rationalize the denominator. So I have the square root of 5 over the square root of 2, and I'm going to multiply the top and the bottom by the square root of 2. On square root of 2 times square root of 2 just gives me 2. The square root of 5 isn't anything good. Square root of 2 isn't anything good, so I'm going to put them together, and I'm going to get the square root of 10. There's no hidden perfect square inside the square root of 10, so this would be as simplified as you could get it. That is how you rationalize the denominator. That's how you get the square root out from the denominator of a fraction, since you can't leave it there. That concludes this lesson. The homework for everybody is on page 390. It is 2 through 24 even.